Hey there, quantum enthusiasts. Today, we're diving into a fascinating concept that could revolutionize the way we build quantum computers. Imagine a future where these powerful machines are not just a scientific curiosity but an everyday tool. Well, that future might be closer than we think, thanks to a groundbreaking idea from Quantum Source. So, what's the big deal? Quantum Source has proposed a hybrid approach to quantum computing, combining the strengths of photons and atoms. Now, this might sound like a simple idea, but it's a game-changer for addressing a critical challenge in the field: fault-tolerant quantum computing. You see, the holy grail of quantum computing is achieving fault tolerance, which means making these machines robust enough to handle errors and deliver reliable results. But here's the catch: it's not just about having powerful qubits, it's about scalability and connectivity. Let's break it down. Current quantum processors have made incredible strides, but they face a common problem. Whether it's superconducting circuits, trapped ions, neutral atoms, or photonic processors, they all strive for the same goal: error correction that's good enough for fault tolerance. And this is where Quantum Source's idea shines. They've proposed a compound photon-atom architecture, which is like a quantum superhero team-up, bringing together the best of both worlds. Here's the genius part: they use a reusable photon-atom unit cell, which is like a tiny quantum factory. This cell, based on a trapped rubidium-87 atom inside a high-finesse cavity, can perform near-deterministic entanglement, photon generation, and quantum operations. Think of it as a quantum assembly line, churning out entangled photons and atoms like clockwork. This is huge because it tackles the scalability issue head-on. By reusing this unit cell, they can significantly reduce the hardware overhead, making it more efficient and cost-effective. But wait, there's more. The real magic happens when we talk about connectivity. Photons are like the social butterflies of the quantum world. They can travel long distances and interact with any part of the machine, making them perfect for establishing connections. However, the challenge has always been creating that initial entanglement. Quantum Source's blueprint solves this by using a single, reusable compound photon-atom building block. This block performs the platform's most crucial physical operations with near certainty, and when you put it all together, you get a fault-tolerant machine. Now, you might be wondering, why is this such a big deal? Well, in the world of quantum computing, connectivity is king. It's the key to achieving reliable error correction at scale. And no single hardware platform has managed to crack this code, until now. Superconducting processors are fast but lack long-range connectivity. Trapped ions have excellent gate fidelities, but they struggle with scalability. Neutral atom arrays can rearrange connectivity, but it's a slow process. Enter Quantum Source's solution, which flips the script. Photons provide the long-range connectivity, while the atoms excel at controlled quantum interactions and temporary information storage. It's like a well-choreographed dance where each partner plays to their strengths. The reusable unit cell is the star of the show. It's not just a hardware component, it's the linchpin that brings the entire architecture together. By using direct photon-atom interaction, they've eliminated the need for strict photon indistinguishability and massive multiplexing overhead. This simplicity is a breath of fresh air in a field often bogged down by complexity. And the best part? It's all backed by numerical analysis, showing how these building blocks can be assembled into a fault-tolerant quantum computer. The proposed architecture uses the measurement-based model, which is like a quantum sewing machine. It stitches together a large, entangled resource state, and then computes by measuring it layer by layer. This approach is brilliant because it simplifies the computation process and leverages the strengths of both photons and atoms. The atoms act as reusable stitching points, tying together photonic qubits into a complex computational fabric. It's like a quantum tapestry, where each thread is a qubit, and the atoms are the needles that weave them together. But what about the numbers? Quantum Source has simulated the system's behavior and provided a transparent assessment of its performance. They've estimated a photon loss threshold of around 2.6% per physical gate, which is impressive. This means the system can handle a significant amount of photon loss and still operate fault-tolerantly. And they've also outlined the path to universal computation, which is the ultimate goal. Now, some might argue that this is just a blueprint, not a finished machine. And they're right, there's still work to be done. But what Quantum Source has achieved is remarkable. They've provided a clear roadmap, showing how this hybrid approach can lead to practical fault-tolerant quantum computing. It's like they've given us a treasure map, and now it's up to the quantum engineering community to follow it and uncover the riches. In my opinion, this is a significant step forward. It's a fresh perspective that challenges the traditional approach to quantum computing. By combining photons and atoms, they've created a synergy that addresses multiple challenges simultaneously. It's like a quantum symphony, where each instrument plays its part, but together, they create a harmonious masterpiece. Personally, I find this approach incredibly exciting because it demonstrates the power of thinking outside the box. It's a testament to the creativity and innovation that drive this field forward. So, what does this mean for the future of quantum computing? Well, it opens up a world of possibilities. It shows that by combining different quantum systems, we can unlock new levels of performance and functionality. It's a reminder that sometimes, the best solutions come from unexpected collaborations. And who knows, maybe one day, we'll be using quantum computers built on this very blueprint to solve some of the world's most complex problems. That's the beauty of science and technology, the endless potential for discovery and innovation. Stay curious, my quantum-loving friends, because the future is quantum bright.